In this example, we were given that theta is an angle that terminates in the second quadrant, so it's somewhere over here. So I've represented it at this location here where the angle actually ends. The takeaway is that whatever theta is, it's greater than pi over 2, but less than pi. I'll state that as a fact here. This is important to note for this problem because sine of theta, which we're given, has to be a positive number. Sine by definition is a y value, and the y value must be positive if you're in the second quadrant, and in fact we're given that it's positive 2/9. The first thing you have to do to solve this problem is you have to find cosine of theta before you find cosine of 2 theta. Well, whatever this is equal to, because cosine is the x value, we know that cosine, whatever it is, it must be a negative number. Therefore, if you use an identity to first solve for cosine of theta, if you ever have to make a decision as to if it's positive or negative, this fact will allow you to choose that. So I think it's important we actually go over this process. I'm going to use an identity to solve for cosine of theta given this information up here. I'll put that work over here. The identity I'm going to use for this is sine squared of theta plus cosine squared of theta is always equal to 1. We're given this is 2/9, so this means you square 2/9, and then you have to solve for cosine of theta using this piece here. If it turns out that if you use this identity and you have to make a choice between plus or minus, you got to go with the one that is negative. So let's actually see that happen from this identity. So in place of sine, I'm going to replace it with 2/9 squared. And I'll write cosine squared of theta over here. This has to be equal to 1. To solve for cosine squared theta, I'm going to subtract 2/9 squared to the other side. This means that cosine squared of theta is equal to 1 minus 2/9 squared is 4 over 81. And if you subtract 4 over 81 from 1, you get 77 over 81. I will continue this work over here. What we've concluded is cosine squared of theta must be equal to 77 over 81. But that's not cosine of theta. To solve for cosine, you'd actually have to take the square root of both sides. And when you do, you have to put a plus or minus over here. The left is going to be cosine of theta. The other side is going to be plus or minus. The best way to write this would be to split up the square root and call it root 77 divided by the root of 81 is 9. So I'll put root 77 over 9. So here, in the identity, we have a choice to make. There are two possibilities for cosine. It's either the positive or the negative of this. And from what we stated up here, well, cosine has to be negative, and therefore we get cosine of theta is equal to negative root 77 over 9. The takeaway from all of this is, if you use an identity and it forces you to make a choice, this quadrant tells you the correct choice to make. If you use an identity and it doesn't give you a choice to make, then the decision is essentially made for you. Let's take a closer look at this by finding cosine of 2 theta, and I'll put this on the next slide. Now let's compute cosine of 2 theta with all the same information. Theta terminates in the second quadrant, meaning it's between pi over 2 and pi, and I stated that information here. If you want to figure this out, you could first start by asking yourself, hey, should this be positive or negative, whatever our answer is? Can we even figure that out based on the angle 2 theta? The question you should ask yourself is, what quadrant is the angle 2 theta in? If the angle is in the third quadrant, well, I know then we would choose negative. If theta was in the fourth quadrant, then I know I would choose to do positive. The reason is, if the angle 2 theta was in the second quadrant, the x value would be a negative number. If 2 theta was an angle in the fourth quadrant, oh, well, then I would choose a positive number because the x coordinate would be positive. So where is 2 theta? You can use this identity to put a 2 here, provided that you multiply 2 here and here. So I guess what I'm saying is, if you want a 2 theta, you can multiply through this inequality by 2. And what you get is, these two cancel, and you're left with pi is less than 2 theta is less than 2 pi. So where is the angle 2 theta? Well, it has to be bigger than pi, and it has to be less than 2 pi. This means we have no idea which quadrant this angle is. So the answer to this one is no idea. I have no idea where the angle is. And that could really affect if the answer should be positive or negative. Again, if it was between pi and 3 pi over 2, we would choose negative. If it was between 3 pi over 2 and 2 pi, we would choose positive. But we cannot make that decision because we don't know where this angle is. But the good news is, to solve for cosine of 2 theta, you can use the double angle formula for cosine. There are 3 versions of it, but the one I'm going to use is cosine squared theta minus sine squared theta. So what we can do is, I can still try to use this identity to solve for cosine of 2 theta. If during that process I never have to make this decision, then whatever the sign is on this, positive or negative, is going to be the sign that we use. So I'll continue that work over here. Cosine of 2 theta is equal to, well, we just figured out what cosine is. It was root 77 over 9, and it was negative, and we're squaring it. And then sine was 2/9, and we're squaring that as well. So to solve for cosine of 2 theta, I just have to perform the arithmetic on this. Okay, so we're squaring the negative. That becomes positive. This will be 77 over 81. So I'll say, okay, this is 77 over 81. And we're subtracting 4 over 81. The difference that we end up with is 73 over 81. And we did not have to make a decision if it was positive or negative. The decision was made for us by this identity. So again, the answer to this question is, when you're deciding on something being positive or negative, you only really need to make that decision if, for example, you take the square root of both sides and get a plus or a minus. That does not happen in solving this formula, and that's why the value for this is positive. So by the way, since this is positive, now I do have an idea of where the angle 2 theta is. And it has to be that it's over here in the 4th quadrant. We didn't really need to know that for this problem, but that is where the angle 2 theta is located.